Hello. Wow, take two or a day and a half off and everything suddenly feels all brand new again. Welcome everyone. Thank you for joining me on this fine evening. It's very cold here, although I'm sure people who live places that it's actually cold think I'm a big wimp. So let's see, where did we leave off? It really has been a couple of days. I know I said I was going to stream again on Sunday. My cat ate my mouse, or more specifically the cord of my mouse. And by the time I went out and bought a new mouse, actually several new mice, it was too late to stream. So that's what happened there. All right, let's see here. So last time we basically laid out the whole PPU scan line cycle, or really the whole frame cycle, I think. And yep. So now all we have to do, is we've got to go through and make sure that that's correct and that it's clearing all the flags and doing all the things that it's supposed to do. And then we're going to want to start actually rendering things, which will be very exciting. I'm going to try to do that in a sort of a high fidelity way, if you will, and kind of go cycle by cycle, loading the actual shift registers and whatnot that exist in the PPU, and so hopefully that'll be doable. Hi Lila, how you doing? Well, right off the bat, that's not so much correct as it is completely wrong. The scan line needs to wrap, I guess, at the end of the unused name table fetch, which is 340. Good, a few minutes till bed. Okay, great. Enjoy your evening. Where's my stinking... I guess it's after test sprite. It's amazing how quickly you just flush absolutely all context out of your brain when it's been a couple of days. Alright, here we go. So, how do we get out of this? NT, AT, background. These unused NT fetches are not quite correct, are they? Because stuff needs to work pretty quickly. Yeah, no kidding. I'm a little bit behind at this point. Where do I wrap the cycles? So this says wait for end of scan line. Oh, I get it because it bumps back over here. Okay. Got MMC3 to implement for SMB3. I don't see that to be a huge issue, although maybe I'm overly optimistic there. But I'm much more worried about the graphic-y bits. If I can get the graphics working, I'm not super worried about the mapper. Okay. Gotta fix the background one now. Right, so what are we looking at here? Okay, we clear V blank at the very beginning. Although, obviously, this is wrong because it's going to clear every single tile. tile equals 0. Then do that. Tile 43 is where the scan line should wrap. So let's do that. Is APU part of the bet? Nope. Thank goodness. I would never make that in time. Yeah, definitely would not be able to do that unless I took a couple days off work. Okay. Every cycle, a bit is fetched from the 4 background shift registers in order to create a pixel on screen. Exactly which bit is fetched depends on the fine X scroll set by 2005. Skipping that for now. Taking time off work to complete a nerd bet. AWAGA would do that. I might. I mean, I've got PTO. Afterwards, the shift registers are shifted once to the data for the next pixel. Every 8 cycles, new data is loaded into these registers. Every cycle, the 8 X position counters for the sprites are decremented by 1. For each sprite, if the counter is still non-zero, nothing else happens. If the counter is 0, the sprite becomes active, and the respective pair of shift registers for the sprite is shifted once every cycle. This output accompanies the data in the sprite's latch, okay, to form a pixel. The current pixel for each active sprite is checked, and the first non-transparent pixel moves onto a multiplexer, right here, where it joins the background pixel. If the sprite has foreground priority, or the background pixel is 0, the sprite pixel is output. The sprite has background priority, and the background pixel is non-zero, if the background pixel is output. That's interesting, okay. So, whoa, hello. Hi, kitty. Oh, jeez, okay. Cat is gonna sit on me. No respect for the bet. Okay. He's a good boy. Even if he did eat my mouse, almost certainly. Okay, so there's primary OAM, secondary OAM. 8 pairs of 8-bit shift registers. These contain the pattern table data for up to 8 sprites rendered on the current scan line. 8 latches. These contain the attributes for up to 8 sprites and 8 counters. The background has VRAM and junk. This controls the address that the CPU reads during background rendering. 2 16-bit shift registers. Pattern table data for 2 tiles. Every 8 cycles, the data for the next tile is loaded into the upper 8 bits of the shift register. Meanwhile, the pixel render is fetched from one of the lower 8 bits. Okay? And then 2 8-bit shift registers. These contain the palette attributes. Alright, so let's do that. Start there. That seems like a good place to start. Struct PPU. BG latch 16 U16 2 BG latches 8 U8 2. Or well, let's see. Pattern latches, attribute latches, and I think I decided that I had attribute fetching all wrong after talking to somebody. fire, probably. Okay. So every 8 cycles, the data for the next tile is loaded into the upper 8 bits of this shift register. So presumably, that is when you do incorrectly. So I guess, when does this happen? You start with the registers full, because that's what these 2 fetches are for, if I remember correctly. Or no, this whole thing is like the next frame stuff, right? Right. So the whole reason is to fill the shift registers with data for the first 2 tiles of the next scan line. So those last 2 fetches, I guess, are the thing. Except that only fetches the... Oh, okay, so these are the first 2 tiles. Okay, I get it. And so those are loaded into the shift register, meaning that at the start here, you already have data, and you're just going to render it out for these first 8 ticks. And then after you fetch the high byte is when you will update it. So, fetch BG high pushes inc_rise, which is obviously when this should happen. Alright, this seems right. Shift registers, I guess, because there's 2 of them. Right, so we're going to do ppu.bg pattern latches 1, just the high bit, or no, 0 and 1, so 0 is the low bit, or equal ppu.bg low byte, and then we'll load this one, right, shifted by 8, or left shifted rather, by 8. As E16, except this needs to be the high byte, obviously. Okay, so that's when it's reloaded. Okay. And so every cycle, a bit is fetched from the 4 background shift registers in order to create a pixel on screen. The other bit is the attribute bit, right, which I did kind of figure that out. Find X selects a bit between these 2, but we're not going to do that right now. We're just going to assume it's the low bit. We get 2-bit palette attribute table. Okay, so we gotta load the palette, obviously, as well. So ppu.bg attribute pattern data attribute latches 0. This says every 8 cycles the latch is loaded with the palette attribute for the next tile. The palette attributes for the lower 8 pixels. Okay. So I think this just assigns, right? Fetch AT is right here. We assigned it to attribute latch, I guess. There's supposed to be 2 of these, though. These registers are fed by a latch that contains the palette attribute for the next tile. Oh, okay. I sort of remember this because the attribute index is only 2 bits, I think. And so it just needs to match up, which I guess is why there's this 1-bit latch. Do they all have the same attribute? I swear to God, I just learned this like a couple days ago. Just check something here. Right, okay, so the palette is selected by the attribute table, and that can only be used once per tile. So it's basically just gonna match, right? Like, just load this whole thing with attribute latch. Seems approximately correct. Oops. Okay. Each clock cycle produces 1 pixel. So every 8 cycles or so, okay, so, this is when the sprites are fetched and stuff. Okay, so it's actually got nothing to do with that then, right? Like, hang on. Are we fetching? I guess we are, right? We're updating the tiles 1, 2, up to here. And then 8. Well, these are the sprites. And these are the first 2 tiles. So this doesn't actually sync up, does it? What are these fetching to? Man, this thing's weird. So what's the resolution? Exactly. I think it's... So this is 240 lines of pixels. And how many pixels across? 262 scan lines, and 20 of those are spent in V blank. 240 by 240, duh. So, I feel like maybe I'm overthinking a little bit. Overscan. Okay, so the PVU always generates a 256 by 240 picture. That makes sense. Wasn't there an image to show the dead zones and sizes? I don't know, maybe. Like this? Is that what you're talking about? Yeah. Okay, well, I mean, basically what this comes down to is that the documentation's bad. Because it says that every clock cycle of the 341 produces a pixel, but it doesn't because that's too many pixels. Because it's only producing 256 by 200 and whatever, 240, which matches this picture much better because it's all of these cycles, right? 1 through 256. And then 240, these are the post-render cycles, so they don't produce anything. So that makes way more sense. Look, there's dimensions. You mean in this picture? Yeah, okay, so this makes way more sense. Anyway, so that's that. And then during the OAM clear and the sprite evaluation for the next scan line is when we need to update the sprite stuff, but we can wait for that. So what this means is that during those first 8 cycles, or those first 256 cycles rather, is when we need to actually do the drawing bits. So what is that going to look like? Oh, hello, kitty. Oh, they're both in here. Observe my cat. He's a good boy. Okay. Okay. They're both there to eat more mouse. Well, joke's on them. My new one is wireless, so they're going to have a harder time. Can't just eat the cord, gotta eat the whole mouse. Cycle. Scan line. I probably don't need the scan line part. Oh. Goodbye. Alright, so what we're going to do is we're going to do a bit is fetched from the 4 background shift registers. Okay, so let BG index equal fetch bit GPU dot. Don't challenge them. Yeah, that's a good idea. BG pattern latches. right shifted by cycle mod 8. I mean, this is the fetch bit, I guess. Cycle mod 8 and 0x01. And then let palette index equal PPU dot attribute latches right shift cycle mod 8 and 0x01. Oh, and obviously this is going to be a problem. So BG index low, BG index high, 1, and then these contain the pattern table data for updated sprites. Yep, so again, this is going to be palette index low, high, BG index equals BG index low or BG index high left shift 1, SBG palette G. Okay, so there's that. So we got both of those. We're kind of cheating based off of find X. And then we're going to skip sprites. So to do add find X, to do add sprites, and priority, and then pixel. So let pixel equals, now we're going to use the attribute data. Here's the memory map. Is there a PPU memory map? Yeah, here we go. Right, so we've got a pattern table, or 2 pattern tables, and then we have the name tables, and then we have palette RAM indexes, of which there are 16 bits. So dang it, I had this figured out at one point. So the background pixel color is chosen by 2 bits from the tile. Yes, selecting one of 4 colors in a palette. Right. Okay, so we select the palettes offset from F to get, okay, that's how that works. So then let palette equal background palette, I guess, 0x3f00 plus palette index, right, times 4, I guess. Each palette has 3 colors. Each 16 by 16 pixel area of the background can use the backdrop color and the 3 colors from one of the 4 background palettes. So each of those is 3 bytes long, which is just to annoy me, presumably. The choice of palette for each 16 by 16 pixel area is controlled by bits in the attribute table at the end of each name table. Each sprite can use the 3 colors from one of the sprite palettes. Right, so we did that. We've got the thing. We've got the attribute table byte, which means that let me equal what now? 16 bits. I was not specifically talking about you, but sure. Oh, hey, thanks, Pixel. You donated 1 whole bit. I appreciate it. That makes you the second person ever to do that. Literally not even your 2 cents. I do appreciate that. Okay, so... Gosh, this is a mess. Okay, so... we start from here, and we offset by this much. Okay, so we should just probably make this a lookup thing. Right, so... pixel address, you're going to take in a palette index U8 and a color index U8, background index U8. If background index equal to 0, 3F00. Else, zero x3f01 plus palette index times 3 plus background index. Right? Right. Okay, and then we're gonna do pixel address equals pixel address, palette index, background index. Probably doesn't strictly need to be a whole other function, but whatever. I was working through it. Address is 3F, 3F8. Oh man, come on. You gotta be kidding me. Alright, so this is actually plus it times 4, which makes way more sense. Oh. Meow, meow, meow. Hi, buddy. These addresses can contain unique data, though these values are not used by the PPU when normally rendering, since the values would select background color anyway. Can still be shown using the background palette hack name explained below. Alright, well, whatever. So what actually is supposed to happen is that you're supposed to start from 0 here, except that it gets sort of... there's holes because they select the background color. Alternately, you could just select those, but then it wouldn't actually work right. So, okay. So that's the address. And then let pixel color equal PPU dot mapper get byte PPU address. Okay, that's how you get the pixel color for the background. Hello, kitty. And then we've got to figure out how to actually draw this stuff, I suppose, which involves drawing to the frame buffer, which we just decided was 256 by 240. So let's go ahead and add that in. Struct PPU. Frame buffer. U8. Which one? So that's X. So this is going to be U8 240, 256. I don't know how bad two-dimensional arrays are going to turn out to be in Rust, but we're going to find out. PPU.FrameBuffer cycle scanline equals pixel color. Assert cycle is less than 256. Assert scanline is less than 240. Okay. That seems about right. Now this needs to get called every single cycle, as long as cycle is less than 256 and scanline is less than 240. Or it could just be called every cycle and just return if those things are true. If cycle greater than 256 or scanline greater than 240. Yes. Yes, it should. Good catch, Serotonik. I bet there's other stuff like that that doesn't build. Do. Okay. Start with this. BG pattern latches is going to be U80, or not U80, 02. This is also going to be 02 for attribute latches. Gosh dang it. 2 for attribute latches. Frame buffer 0 to 40 to 56. Go. 67 as U16. As U16. Expected nothing, found U16. Oh, because it's not returning anything currently. I don't know why I assumed that would be inferred. It's obviously not going to be. These need to be as usize. Bum. Attribute latches are BG attribute latches, although I think they probably apply to both. I'm not really sure. Expected U8 found U16 for BG index. Okay, let's just make it a U16. It doesn't actually matter. Okay, it builds now. None of that's getting called ever, so it doesn't matter, but it builds. So now we should probably call it, huh? Trying to decide. I do have a little bit of an issue here in that by passing cycle counts in as part of the operation state, I don't really have a clean way to get at them other than by reading them out of the sprite state, which I guess is fine. It's not like we're not going to have a sprite state. So let's just doink. doink. And then we'll do, gonna have to change that name. See if that just explodes. Oh yeah, because it needs to be sprite state dot. Do. Oh, it's draw you bits, not draw you stuff. That's what I get for being cutesy. Can't even remember how cutesy I was. Alright, explode, please. Hey, look, it exploded. Assertion failed, address is less than 3000 in NROM mapper. Well, that seems sensible. Sounds like I didn't implement a big chunk of RAM. Oh, okay, maybe it's not right, actually. I bet this will be something nice and easy to fix. Address is 3F00. Yeah. So 3000 up is supposed to be a mirror, except for 3F and so on. So do we have a... How big is the Chur RAM? It's only 2K, which is probably why it asserts like that. So there's palette RAM, or is that like different somehow? How? Oh, that's clever. Is this just like fixed, or... Because it specifically says palette RAM. I mean, it must not be fixed, because otherwise you couldn't change it. So is there just like extra RAM? Is that what's going on? Like extra secret RAM? It's not in the OAM. Not configurable, always mapped to the internal palette control. Okay, but can you change that? This is what I'm finding confusing. So... Some emulators decode the NTSC signal in real time, others use a predefined palette. Okay, so I should just do this, I guess. Sometimes people want something functional. Yep, that's me. Still no Halloween decor, SMH. This palette is intentionally similar to the addresses to the NES's standard palette, but notably is missing the grays in entries 2D and 3D. The TCO3 is used in versus .con versus 10S all play choice games with Famicom titler. So I'm very confused. 2CO2. This doesn't seem like enough bits. Right? Because it stores these as hue and brightness. I'm so confused. You sound tired. I am tired, man. I have had a long couple of weeks. So it really seems like you should be able to set the palettes, because it's called palette RAM. But there doesn't seem to be any case where you would actually do that. I mean, unless you're going to set it through OAM data and whatnot, which I guess you could do. How do you change the palettes? Like, I guess you could write directly with PPU adder. But before the palettes, reading palette data works differently. There's no dummy read. But what about writing? All right, well, okay. So first off, let's go in here. And in the draw bits function, this is slightly wrong because it's not an actual color, it's a pixel color index. And then you need to do lookup right. So you've got this, and then you need to do ppu.ntsc to RGB or something like that. pixel color index, and that's where we'll fill in one of these tables. And then in the nrom mapper, we're going to give ourselves some palette RAM, which I guess could be fixed size. U8. How big is that? 7 bits, 128 bytes. That doesn't seem right. And it's not. The palettes are, what, 4 bytes? I was just looking at this. Where'd it go? Yeah, so they're 4 bytes. So this is up to 16. Okay. And then we'll just say else if adder greater than or equal to 0x3f00u16 less than 0x 4000 u16 self dot palette RAM address and 0x1f, I guess. To get the mirroring behavior correct. We need to initialize it. And then same thing here. What was all this about? Oh, comma. How are you doing, Spy Crab? You say I sound tired? Are you having a grand old time? Self NTSC byte, which is a U8. I should be long asleep. Yeah, man, go to bed. Sleep is important. These are 7-bit values or 6-bit values because there's an emphasis bit. That's why. So it's a 7-bit value, which is why this is a 7-bit palette. So this is going to return U32, and we're going to have NTSC lookup table. Not going to make the lecture anyway. It's wasting your education, my man. You sound like you need some sleep too. Yeah, I absolutely do. As soon as I get this, as soon as I kind of just like, I don't know. Once I've done this for a while, I'll go to bed. I really want to finish this before the deadline. I've been enjoying it. And I would like to just like finish something. I have a problem with not finishing things. Oh, it's actually less than that. It's only 6 bits. So 64, I guess. And then all this is going to do is NTSC lookup, NTSC byte as usize. And then when we populate this, I wonder if I could put like a const fun there or something. You can do it. Thanks, Diana. Got to admit, this is not my best day, but that's okay. I need to do a thing, so let's, okay. $32.8. Nope, not 8, 64. Zero X 00 84 84 84. $30 16. Actually, hang on. Set, paste. Just copy this. Paste it. Get rid of this so it'll all fit on a slide. Get rid of that. I want to break this up a little bit more, but I guess this is fine for now. Set no paste. Just gonna go through like this. Oh geez. That didn't work, did it? Feels like it should. Guess not. All right. Do 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 dee 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 dee. Let's just move these out of the way, hey. Okay, so that's 1, 2, 3, 4. Gonna put a 0x on the front of these. Gonna replace these with an underscore. Do 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 do. Gonna replace all of these. Oops, with a comma. Gonna displace like that. There we go. Okay. And then we're gonna go ahead and let's see here. 1, 2, 3, 4. La la la. Copy the palettes. These aren't hex numbers. Gosh darn it. Sorry, buddy. My leg's falling asleep. Need you to get up for a second. Okay, there we go. Yeah, these aren't hex numbers. Let's just make it a U8 thingy. What say you? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, whatever, good enough. 64 times 4 is 256. U8s. I wonder if you're allowed to even have leading zeros in Rust. There you go, bud. Whoop. Yeah, there you go. Get up and off. Sit on the cat chair. Ugh. Okay. Doop-a-doo. No octal prefixing. Thank God, no. Who, has anyone used that on purpose ever in the world? I can't imagine octal being relevant even back in the 60s, 70s, whatever. Whenever the hell that was. Never use it in Rust. Certainly not. I mean, octal is dumb. Like, yeah, for Unix permissions, right, which is also dumb. Like, just use the symbolic thingies. Da, 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 da. Don't think the actual POSIX API supports those. I would believe that. Wait, what did I just do? No, okay, this one is a legitimate zeros. And then 0. Zero. This is not a super interesting stream, I know, and I'm sorry about that, but some days you gotta copy palette data over and stuff, I guess. Don't know why I keep humming a Game Boy song. while working on my NES emulator. Alright, how many is that? 4, 8, 12, 14? Yeah, this isn't quite right, is it? Oops. Awesome. Alright, let's see where I screwed up. I'll put some extra spaces in here so I can see the difference. Okay. 84, 0, 30, 116, 8, 16, 144, 48, 0, 136. Okay, so that worked. 68, 0, 100, 92, 0, 48, 84, 4, 0, 60, 24, 0, 32, 42, 0, 8, 58, 0, 0, 64, 0, 0, 60, 0, 0, 50, 60, 0, 0, 0. Okay, so I guess that is correct. I don't know what I was looking at that made me think it was not correct. Unless there's more that is illegible because of the screen scroll? No. Okay, so that's fine. I don't know what I was looking at. Whoops. Okay. Only 2 more of these stupid lines. Ah. Anybody do anything interesting this week? Let's talk about that instead of just staring at numbers. Octal kind of makes sense for the permissions. Yeah, okay, kind of. But, like, is it even octal, though? It's really more like just 3 hex digits with their range restricted. Like, I know it is octal, but if you wanted to think about it that way, it's not like you're not talking about it as a whole octal number, I guess is what I'm saying. you are talking about it as like a series of bit fields, which could really be in any base that is larger than the size of the bit field. It's possible there is some weird circumstance where you do care about it as an octal number, but I can't think of one off the top of my head. Okay, getting there. So I bought a new mechanical keyboard at work because I was getting carpal tunnel from my crappy rubber keyboard there. And here, my keyboard is, what do we call them, Cherry MX Clears, which I like, but I wanted to try something else just to see. And I went with browns, which are basically the same as clears, but lighter. And I am not a huge fan so far. It seems like it's too light. I thought about getting blues and swapping with this keyboard because blues in the office would be madness. But I sort of wish that I had done that now. The browns aren't bad. Maybe I'll get used to them. They feel too light for my big gorilla fingers. Okay. Equal sign. Build. I know you're going to fail, but let's see here. Expected an array with a fixed size of 256 elements, found one with 224 elements. So now the question becomes, did I screw up the palette, or do I just not know how many numbers there are in the world? So 3F is 40 times 8, or not times 8, times 4. 256. So where's the ones that I'm missing? This doesn't seem like enough bits. Each triplet represents the sRGB color. The following table was generated using Flarg's full palette demo. Hmm. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56. Yeah, see, this is only 56 rows. Are the last rows just always 0? Alright, we're just going to assume that the last 2 rows are all 0? That doesn't seem right. What dumb thing am I doing here exactly? $16, $32, $48, $64. This is just not enough data. Oh, nope, that's all binary. Never mind. Right, I'm not crazy. Each of the 3 video channels uses a 3-bit DAC driven by a lookup table inside the ROM. The lookup tables are given below. 1 digit for each of red, green, and blue in order. (64 by 9 bits). Okay, I think it is just 2 extra zeros because this talks about missing the grays in entries 2D and 3D, which is what this would match, right? These would be the grays, and that would become 0, and then there's 2 extra rows of zeros. So I'm just going to assume that it's all zeros. Because that seems to make the most sense to me, even though, again, the documentation kind of sucks. Go, baby, go. All right. Yeah. You're missing NTSC lookup. Okay. So, if you split it, struct PPU, instead of being U32, you're going to be a U8 256. NTSC lookup. Or it's going to be right here. NTSC lookup. That should just work, right? And then expected U8 found U32. And also this is wrong. For I in 0.4. Let mute color equal 0. Color or equal NTSC byte plus I as U size left shifted by I times 8. And that'll cause us to end up with what format here exactly? So this is red, green, blue. I had ARGB. This would actually give us ARGB BGRA, I guess, which is probably not a real color format. ARGB is probably a better choice. So let's do 24 minus color in ARGB format. Okay, and then pixel color, which is the thing that they don't like. Oops, that's not how you spell it. XL. Okay, so the frame buffer needs to become U32s instead of U8s because we need all the colors and stuff. PPU not found in this scope because it's self, not PPU. Expected U32 found U8. You gonna see picture out with this stream? It seems unlikely, but maybe. Expected U32 found U8. Yeah. I mean, I am gonna, after this point, be filling out the frame buffer will be filled, and so I guess the next logical thing to do would be to oh yeah, I did that at the wrong point, didn't I? The next logical thing to do would be to try to actually render it, so maybe I'll do that. dump it to a file. Yeah, I could do that too. This part's going to be tricky for me because I just honestly don't know that much about graphics stuff. And so oops. Like I could dump it to a file and then not actually have any idea how to display it. We could give it a shot though. Okay, so we're just kind of chewing along. That's good, I guess. Yeah, okay, so this is what we're going to do. We're going to dump to a file here. GIMP has a raw image loader. Oh, that'd be good. Yeah, that's a good idea. Let's just dump it to a file before we spend a bunch of time trying to render it, because otherwise I'll have no idea whether it's like busted or not busted or what. So, okay. It's the best way to do this. I guess just for x in 0 dot dot 256 for y in 0 dot dot 240. Or check out the PBM file format. PBM file format. Portable bitmap. PPM, PGM, PBM. Designed to be easily exchanged. Dump out a 2-byte magic number. ASCII or binary. I think probably portable pixmap is what we would want, right? Because it would be (0 to 255 for each RGB channel. That seems correct to me. 24 bits per pixel. Yep. Okay, let's do that. All right. So first, we're gonna open a file. It's been a while since I had to do that. Let's take a look at it. Let mute file equal file open framebuffer.ppm. File.write all. I should just open the. Okay, so it implements write, which is probably the trait of relevance. Write just writes a buffer, so that should be good. And then we're probably going to want a byte order to dump it in the proper order. Although I guess it doesn't matter. So we're going to want to slice it. But yeah, okay. So, all right. Shouldn't there be a way to like 2BE bytes? Yep. That's what we want. Okay, so then let pixel equal PPU dot frame buffer x y file dot write pixel dot 2BE bytes brackets 1 dot dot, and then before that file dot write we need to dump out the magic bytes, which are P6. Okay. And then we're gonna panic. See what we get. Go. Nope. Fair. Some other junk that I screwed up. Well, first of all, I wrote fire instead of file. That'll get you every time. What are all these other problems? Use of undeclared type or module file. Expected expression. Oh yeah, that's completely correct. Just missing a close brand. And then use standard FS file. Go, 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 go. Nope. Gotta use standard IO write. And then it'll work. Nope. Consider borrowing. Yeah. Oop. Go. The system cannot find the file specified. Well, it's probably supposed to be like create or something. Yep, it's create. Boom. Okay. So let me navigate over there. Oh, it actually came up as an image format, but then it said unknown image format, general error. Cool. Header should be P6 new line ASCII width space ASCII height new line. Okay, thanks. That helps. That probably would be easiest with write format, huh? Writes a formatted string into this writer. The write macro should be favored. Okay, fair. All right. Write and mute file P6 new line width space height new line 255 new line, you said? Okay. 256 240. Go. Oh, okay, that makes sense. Bit depth. You gonna open this time? Hey, it opened. Doesn't really look correct, I don't think, but it's something anyway. I don't know, maybe it is correct. Who knows? Let's let it run for a little while and then explode, huh? Because the first frame of Donkey Kong might look like this for all I know. Alright. No, you can't really do that, though, can ya? Alright, here's what we'll do. Struct PPU. Oh, I have a cycle count. If PPU.cycle count is greater than 4 million, do this. Close that. See what we get. Probably should print less. 4 million is going to take a while at this rate. Yeah. Alright, yeah, let's do this. Let's run this without speed. Oh. One of those was important, apparently. What's the matter, you? 747. What? Oh, okay, I see what happened. I screwed up. Now let's try it. Go. Okay. That must be in the NROM mapper, huh? Yep. Just go ahead and get rid of that. I don't really need it. Okay, no more printing of any kind. Just go. Maybe I should have run it in release. There we go, explicit panic. That didn't take very long at all. Good. Let's see what we got. It's gray. Well, this is obviously not going to yield an enormous bounty of knowledge. I'm going to do one more run of this because I really hope that I get something cooler to look at. And in the meantime, while it's running, let's make it 16 million. I'm going to go and get some water. I'll be right back. Literally just like, I don't know, 60 seconds. Okay, I'm back. All right, there we go. Let's see. Nope, still gray. Okay, so there's definitely something iffy. I mean, I guess it's possible the background on Donkey Kong is 100% gray at the title screen, but that seems unlikely. So obviously the next thing to do is to try to actually render this live. It will yield a tremendous increase in usefulness of this nonsense. Anyway, any way of making snapshots as it tries to build the image to see any differences? I mean, yeah, sure. I could do that. What if we did this? This is so silly. Like, this is such a dumb thing to do, but it'll be fun, so who cares? CPU.cycle count. And then we'll get rid of the panic. Actually, no, we'll leave the panic in if CPU.cycle count is greater than 4 million again. Oh, unexpected close delimiter. What did I do? Oh, okay. That's what. All right, we're just going to try to dump it every time the scan line wraps. Oh, well, that's troubling. Oh, okay, I know what I did wrong. All right. Beep. Yeah, I need to do if cycle is equal to 256 and scan line is equal to 240, then do this. That looks saner. All right, that's enough. Oh, I guess it would have hit that in a minute anyway, but I wish that it would go through it like Windows Photo does. Does Windows Photo know how to open these things? Probably not. Where's open with? Oh, there it is. Well, from just selecting them at random, they all appear to be gray squares. So not terribly enlightening. I wonder what value that turns out to be. Okay, whatever. This has been fun, but it's not actually useful. So let's take a look real quick at, oh geez. Switch from P6 to P3 and sec the image file text. Oh yeah, okay. I would have to dump it as ASCII though, right? Instead of as the bytes, which I'm doing right now. I mean, not like that's hard. So for the ASCII formats, it's just like space separated. Yeah, okay, for RGB triplets. All right, yeah, why not? We'll do one more thing, and then I'll take a look at it. For I in 0.4. Format. Or no, it would be write and mute file squiggle. Actually, I'll just do it this way. How do I know when to put a new line in? Is that just when you get done with the height, I guess? pixel dot 2be bytes brackets I. And then at the end of our line, we do that. Oh, but we probably want to go X first, huh? That was probably wrong in the other case, too. And then the format is still ppm, I guess. So let's see if that worked. Do. Well, it's a much bigger gray square. Just take a look. It is all 84 all the time, which is palette value 0. Shocking, I know. Let's see, what time is it? Okay, I think I probably am going to shut it off and go to bed now. Next time, what we will do is, I actually do have a, we look at main.rs real quick, with the help of Pixel, or not Pixel, Nick, among others. I do have a way to display some stuff on the screen, and so hopefully I can just render to this texture here with my frame buffer, and we'll try and get that working next time. I don't really have the energy for that tonight. I'm sorry this was kind of a low energy stream, but hopefully tomorrow I'll be able to kind of bring it back. Thanks everyone for showing up. I appreciate it. I know it's, a weeknight. Monday evening is maybe not prime time for watching somebody code, but I appreciate you coming by. Fire Ends, Imonster, Spy Crab. Oh, it's Tuesday. You're right. Holy cow. Okay. Pixel, everybody that stopped by. Thanks a lot for doing that. I appreciate it. And I will be streaming tomorrow, so I'll see you then. Thanks.